These questions are asking for shape, angle, whether or not a molecule is polar. In order to figure that out for all of them, I need to start by drawing the Lewis structure. For NH3, nitrogen is in the 5th column of the periodic table, so it has 5 valence electrons. I have 3 hydrogens. Hydrogen's in the 1st column, so it has 1 valence electron. Therefore, I have 8 electrons to work with. Nitrogen's going to be my central atom because it's the atom I only have 1 of, whereas I have 3 hydrogens. So put hydrogens around it. Now using 8 electrons, 2, 4, 6, 8. Checking if everyone's happy. The hydrogens only want 2. They have 2. Nitrogen wants 8, 2, 4, 6, 8, so we're good. Now that I have my Lewis structure, I can figure out the shape. Knowing that there are 4 things attached, 3 atoms and a lone pair, its general shape would look something like that. But one of them is not an atom, it's a lone pair. So my 3D drawing ends up looking like that. And then looking at that drawing, I know the name of it is trigonal pyramidal. For the angle in water, again, 2 hydrogens that each have 1 valence electron, 1st column. 1 oxygen that has 6 valence electrons. It just so happens, again, we're using 8 total electrons. Oxygen's in the middle because I only have 1 of them. 2, 4, 6, 8. That's my Lewis structure. 8 total. Each hydrogen thinks it has 2. The oxygen thinks it has 8. In order to know the angle, I have to know its parent structure. So again, 1, 2, 3, 4 things attached. 2 atoms, 2 lone pairs. 4 things are going to spread out like that. I don't even have to actually draw it. I know that anything that has 4 things attached and spreads out in this manner is going to have an angle of 109.5. Since there are lone pairs on the central atom, though, my angle is a little less than that number I would expect. To know if BeF2 is polar, I have to draw it. Beryllium is in the 2nd column. Then I have 2 fluorines that are each in the 7th column. 14, that's 16 electrons. Beryllium in the center. 2, 4, 6, 8, 10, 12, 14, 16. Both fluorines believe they have 8. Beryllium only thinks it has 4, but remember it's one of our exceptions that you need to know. Beryllium's happy with 4. Therefore, that's my molecule. Since there are no lone pairs on the central atom, it's not polar for that reason. The other reason it could be polar is if the peripheral atoms were different elements, but they're the same element. So for neither of those things makes it polar, therefore, no, it's not polar. Continuing on with number 25, part D just wants the Lewis structure, so once I draw it, I don't have to do anything else with it, for SO4 minus 2. Sulfur is in the 6th column. Oxygen is also in the 6th column. So that would appear that we have 30 electrons. But the minus 2 means I have to add 2 more electrons. It's negatively charged, so we have extra electrons. 32. Sulfur should go in the center. Also, because it's an ion, my whole Lewis structure I'm going to put in brackets with the charge outside of it. Sulfur in the center, 4 oxygens, using up 32 electrons. Start by connecting them. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. If you consult another resource or a tutor or something and they tell you this is wrong, you might see some actual answers that have double bonds. There's something called formal charge that we ignore in this class. Okay, part E. 3D drawing of Al, that's an L, not an I, Br3. Aluminum is in the 3rd column. Then 3 bromines that are each in the 7th column. 24 electrons. Aluminum will go in the center with the bromines around it. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. It appears that everything's good, but aluminum only has 6. However, aluminum's an exception. It's happy with 6, so that's our Lewis structure. Total number of things attached to aluminum are 3. How do 3 things spread out in space? Like a Mercedes-Benz sign. 1, 2, 3. On your 3D structure, you don't need to show any of the lone pairs that are on peripheral atoms. So this would be fine. If you want to throw those lone pairs on bromine, go for it. It doesn't matter either way.